Assalamu alaikum. In this video, we'll be discussing the laws of counting. Let's learn a few basics and do that with the help of an example. If we have 10 books on programming, 4 on history, and 7 on computer security, and if you're asked how many different 3 books groupings are possible with 1 from each category, how can we do that? We have 10 books on programming, 4 on history, and 7 on computer security. And the condition only is that the 3 group setting should have 1 from each. But there are 10 options for the books on programming, and 4 for in the second category, and 7 in the third category. So 10 possibilities from the first category. For each of these 10 possibilities, there are 4 possibilities from the second category. So if you select one of those 10 books, for every book that you might select, there are 4 possibilities for the second category from which you can select a book. And for the third one, there are again 7 categories. So this gives you 10 into 4 into 7 equal to 280 distinct settings containing 3 books, 1 from each category. And we can formalize this. And this is also known as the fundamental rule of counting, which says that if there are m ways to do something and there are n ways to do another thing, then there are m and n ways to do them both combined. And this is extendable to situations with more than 2 things. There can be m choices for first action, n ways for second, p for third, and q for fourth. In this case, the total number of arrangements that we can have are m into n into p into q. And this can be extended further. The same rule can be applied to count the number of possible arrangements that we can have when we are drawing a sample with replacement. So the principle says that if we have some collection of elements available and we're drawing with replacement, which means that after drawing something from it, we note it down and we put them back. So again, for the next draw, the entire collection is available again. So this principle can be applied to find the total number of different samples that we can have if we know the size of the sample. So if the sample size is 6, which we have to select from a collection of 30, then the number of possible samples, possible distinct samples that we can make is 30 into 30 into 30 into 36 times. Why is this so? It is because first time when you need to select things, you have 30 different options to choose from. For the second item that you have to choose, again, you have 30 different options. And since we have to make 6 selections every time, we have those 30 options available to us. So this gives us 30 raised to power 6 number of different samples that we can draw from this collection with replacement. The general formula for this is n raised to power n, where capital N is the size of the collection and small n is the size of the sample that you want to have. In case of sampling without replacement, if we have to draw a sample of 6 items from a collection of 30, we know that after we make the first draw, the collection changes because now we do not put the item back into it. So the number of possible items for the first draw are 30. For second, they become 29. For third, 28, and so on. So the total number of possible samples are 30 for the first draw, into 29 for second, into 28, 27, 26, and 25 for the last 6th draw. But what is the general formula for this? For this, you'll have to wait, because with this, we will study in one of the later lessons. Suppose we have this problem in front of us, which is we have to find out how many different sandwiches are possible if we can have 2 different types of bread, 2 types of meat, and 4 options for the vegetable. This can be, in order to find out the total number of different sandwiches that can be made from these available options, we can model it using a tree diagram. And we'll find out that a total of 16 different sandwiches are possible. How? In the first place, we have 2 options, which is white bread and whole wheat bread. So for the first option of the bread, Then the second option is for the meat. And again, we have two different options here. We have tuna and cheese. Then we have for each of these options, we have further 4 different options available. And the same way as we constructed the sample space, we construct this tree diagram. And finally, we can count these values to verify that the formula that we learned earlier, it corresponds to that. So here we have 2 options in the first place, multiplied by 2 options in the second place, multiplied by 4 options in the third place. So we have 4 into 4 equal to 16. And we can count the values, the number of different arrangements that we get to verify that we do get 16 different arrangements here. Let's consider another example. There are 2 sections in an exam. The first one contains 5 multiple choice questions with 4 choices each. The second one has 3 true-false questions, of course, 2 choices each. How many ways a student who's only guessing the answers can solve it? In order to solve this question, we need to understand what principles we can apply here to count the total number of possibilities. So the first thing is the first section, which has 5 questions, and for each question, we can have 4 different options. Here, this implies that we have a collection of 4 choices or 4 items that we can choose from, but we do it 5 times. So the total number of arrangements are going to be 4 into 4 into 4 into 4, or equivalent to 4 raised to power 5, which is 1024. For the second part, where we have only 3 questions and only 2 choices for each of these questions, the number of arrangements is going to be, using the same logic, it is going to be 2 into 2 into 2, which is 8. Now, to count the total number of arrangements, for each of the arrangement for section 1, there are 8 arrangements available for section 2. So we need to multiply these together to find out the total number of arrangements, including both sections, which is 1024 for the first section, multiplied by 8 for the second section, which gives us 8,192. So you can see that these are the different distinct ways that a student who's only just guessing the answers can solve it. And now you can well imagine how much score you can earn because the probabilities of getting your answers correct is very low. And even if you can get 1 or 2 answers to few questions correct by just random marking, still you may not be able to pass the exam because you can see the different options which are available, and the probability that you get all of them correct is very low.